You are probably familiar with the Heartware ventricular assist system, but I'll just quickly go over some of the work that's gone before. So the HVAD, you've seen it rather comprehensively described by Dr. Struber in the last talk. Nevertheless, it's just to recap, a miniature implantable blood pump sits comfortably in the palm of the hand, as you can see there. Pericardial placement, so no pump pocket. Capable of providing full left ventricular circulatory support, so that means anything from 2 up to approximately 10 litres per minute, depending on the preload afterload conditions. Oops. Centrifugal design, continuous flow, but nevertheless in the presence of a native heart with some degree of contractility, it will still deliver pulsatile flow, and that can be seen quite easily on the waveforms on the monitor, as well as sometimes it can be palpated as well. It uses a hybrid suspension system comprising a magnetic bearing and a hydrodynamic bearing to support the impeller, so there is no actual mechanical touchdown or point of contact between the impeller and the inside of the pump. It optimises the flow and pump surface washing by ensuring that all areas within the pump are washed and improves the hemocompatibility. It has a thin 4.2mm flexible drive line with fatigue-resistant cables derived from the pacemaker industry. Inside the pump itself, you can see that this is the impeller, this is the magnetic bearing here, which protects the impeller in radial direction. The hydrodynamic bearing protects it in the axial flow. Some of the pericardial benefits of the placement are, as I mentioned, no abdominal surgery, no pump pocket, and the potential to expand the pool of treatable patients, as well as the ability to try different surgical approaches. Our typical recommendation is through a midline sternotomy, but you've just seen a very, what's the word I'm looking for, dynamic example of another way of putting the device in. This particular illustration here also shows a pump that's been implanted through a thoracotomy with an anastomosis of the outflow up to the subclavian artery, and that's a relatively new way of approaching it. It has a very efficient power source. The pump uses only approximately 4 to 5 watts to drive it. The impeller enables very low fluid stress, so hemolysis is not typically a concern under normal circumstances, and we've also provided some very useful tools to improve the surgical time. You saw again Dr. Struber using the coring device there to make the ventricular cavity, or to open the anastomosis site. So, some of the early data. 2 of the largest VAD trials conducted in the US were the Advanced trial and the Endurance trial. The Advanced trial was our bridge to transplant trial. We enrolled 140 patients at 30 centres across the US. An additional 202 patients were enrolled via the continuing access protocol at the conclusion of the initial enrolment. There was a 6-month follow-up completed in August 2010, and that was, we looked at also a contemporaneous comparison with Intermax patients from the registry of nearly 500 patients there as a control. These data were presented to the FDA and a panel presentation on the 23rd of May, and we've since obtained FDA approval for the HVAD as a bridge to transplant. The Endurance trial is still ongoing, although we have completed enrolment of 450 patients at 50 centres across the US. There is a 2-year follow-up, so those data are not yet available. The advanced outcome measures, the primary outcome was to demonstrate non-inferiority to the control group, and that was survival on the original implanted device, or transplant or explant for ventricular recovery at 180 days. Secondary outcomes were survival between the HVAD and the Intermax control, and functional and quality of life outcomes and adverse events. We demonstrated non-inferiority for the primary outcome with a 92% survival per the protocol as against 90% for the Intermax control. The secondary outcomes were also demonstrated, but we did not achieve the non-inferiority. We achieved a parity. And that's not surprising when you look at the 92.9% transplanted or alive on the device. It would be hard to improve on those data, I think you'll agree, and that was at 180 days. Looking at the HVAD survival versus the projected survival, this is the Seattle heart failure model survival curve compared with the HVAD advanced trial, and you can see that there's a big improvement over the predicted survival of patients using the Seattle heart failure model. Similarly, the HVAD survival versus projected survival using the HVAD advanced data, Seattle heart failure model, the continued access protocol, and the BTT data out of Europe, and you can see that the CAP data are even better than the advanced data, and that's possibly due to improved management of the patients, as well as possibly some improvements we made to the design of the pump along the way. Now, to the pump evolution, so that was the past. We're now looking at some of the things. You may have already seen one or two of these slides in the previous presentation. This is the MVAD. This is showing it relative to the HVAD now. You can see that it's a much smaller design. It is nevertheless a diagonal flow axial pump in this particular configuration. The blood enters the pump through the inflow cannula, which is anastomosed to the ventricle in the same way as the HVAD, but nevertheless leaves in a diagonal orientation. The MVAD clinical pathway is as follows, that we are targeting a regulatory submission for 2013, our first human implant. We are expecting to, we did hold an international investigators meeting in November last year in Rome. We have recruited between 8 and 9 clinical sites. The trial is intended to recruit 50 patients with a 6-month follow-up. And we also will intend to study the new feature, PAL controller. As Martin said, we are moving towards improving our peripherals significantly. I won't promise that we're going to have one controller that will manage both pumps just yet, but nevertheless it is something that is in progress. The other aspect of the clinical pathway will be a US investigational device exemption, and that will be commencing following the initial implants of the 50 patients, and we'll look for a pre-IDE meetings to define that indication in 2013 as well. So some of the possible embodiments of the MVAD will be as per the conventional use in patients using apical placement in the left ventricle with anastomosis to the ascending aorta. Alternatively, there's another configuration that may look at sitting across the aortic valve. Similarly, a BIVAD placement with a pump in the left side and the right side, and also potentially a configuration which allows the pump to sit outside the heart altogether with an anastomosis across the aorta for the inflow, and then coming up to the ascending aorta for the outflow as well.
1 minute left, I'm afraid.
Yep. Showing the peripherals, this is the new battery and controller combined, and again we hope to introduce that, or will be introducing that with the MVAD as well. Thank you very much for your attention.